All right, directions here are to sketch the graph, and we've got some double and triple roots in this one. So here's a double root, and here's actually both double roots in this one. So remember on a double root, that's the one where it kind of approaches the x-axis, barely touches it, and heads back up. It doesn't cross over, but it heads back in the same direction it came from. So we've got two double roots here. Now, if we were to multiply this all out and just try to figure out what our leading term would be, we'd have x plus 1 times x plus 1, and that would end up with a x squared plus some other stuff. We don't know. I mean, we could easily figure that out, but we don't really care. I guess is more accurate. And then we'd multiply x minus 3 times x minus 3 because it's squared, and we'd end up with x squared, and again some other terms that we don't really care about. When those were multiplied together, we'd end up with x to the fourth, again, plus or minus many other terms after it. And lastly, it would be multiplied by the negative 2 out front. So our leading term, all we care about here is our leading term, is going to be negative 2 times x to the fourth. And we can kind of just disregard everything after that. We're just looking for our leading term. And hopefully you can start getting a little more comfortable with seeing what our leading term would be. But there we are for right now. Our leading term is going to be negative 2 times x to the fourth. So this time the degree is even. And when you have an even degree, remember it means that the two end behaviors, the end behavior of the two ends are going to be either going the same direction, both going positive, or the same direction, both heading negative. And so we got to figure out which one it's going to be. Now our leading coefficient this time is negative, which means it's going to be starting at negative infinity and ending at negative infinity. It's these ones right here. So as x heads towards negative infinity, as it gets more and more to the left, then y heads more and more negative. So it's going to head towards negative infinity. And remember this, when it's an even degree, it does the same thing on either side. So x is going to head toward negative infinity also as x approaches positive infinity. So as x, or to reword that, as x approaches positive infinity, it gets farther and farther positive, and y is going to continue falling, getting more and more negative. So we know it's starting at negative infinity and ending at negative infinity. And now we got to figure out what's going to kind of happen here in the middle. All right, well, let's look at our roots for that. So here we've got x plus 1 is a factor, and it's a double factor, so it's got a double root, and the root there is negative 1. And since it's squared, it's got a double root at negative 1. So here we go, negative 1. Kind of sketch that out. Negative, I'll put it above the graph. Negative 1, 0. It also has a double root at 3. So here's our roots. So you have 4 roots altogether, but they're both double roots. So remember what happens at double roots, it bounces off. And so it's going to start from negative infinity. It's going to head on up. It's going to curve and just barely touch, bounce off here, head on back down. Now it's got to head back up again because it's got to bounce off this point as well. It's another double root. And then head on down to negative infinity. All right, now you could figure out what your x-axis would be here fairly easily. Or sorry, your y-intercept. Sorry about that. Your y-intercept would be here fairly easily. Remember, for any type of equation, any type of function, any type of graph, your y-intercept is always where x is 0. And so we could figure that out rather quickly. And this isn't a necessary part of it, but let's do it just to kind of remind ourselves. If we had 0 plus 1 squared, that's going to be 1 squared, times 0 minus 3, that's negative 3 squared, and then that times negative 2, so we have 1 times 9 times negative 2, and so this point right here would be 0, negative 18, and so we got some more information here on our graph. One other thing to kind of make note of is look how the entire graph is either less than or equal to 0. There's no positive y values anywhere here. There's no way I can plug something in for x and get a positive f of x. Just something to kind of keep in the back of your head a be helpful to be thinking about the graphs in that way later on. All right, hope that helped.